Hey second graders, today I'm going to show you our second science experiment, which is how many drops of water we can fit on this penny. You did some great guesswork in Google Classroom, coming up with what you think would be the magic number for how many drops we can fit on our penny. A lot of you said under 10, which makes sense, right? Pennies are tiny. A lot of you also made some really great comments saying that it depends on the size of the drops, which is really true as well. So together we're going to see how many drops we can fit on the penny. If you want to do this experiment along with me at home, all you will need is a penny, of course, some water, and an eyedropper. If you have some cough medicine at home or any kind of syrup, sometimes you'll have a dropper. One thing I would recommend doing is make sure you clean it out first so it's only water in the dropper for when you do the experiment. All right, so let's get started and see how many drops of water we can fit on our penny. All right, so our droppers are ready to go. Now we're gonna see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's stop at 10. What do you notice about the shape? So you can see it's all coming together into one big bubble of water, or as we're gonna call this, a dome. So you can see it's bubbling up and over. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's stop again. That dome shape's getting a lot clearer, and you can see all of the water, it's hanging onto each other. These drops aren't separate on the penny, they're clumping, staying close together. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Did anybody guess up to 30? Let's see if we can do more. 31, 32, 33. Look at that dome. 34, 35, 36, 37, 38. You can see, look at that bubble. It's getting bigger than the penny itself. 39, 40, 41. Ooh, all right. So we got 40 drops of water on the penny. So second graders, the reason that was able to work so well and we were able to fit 40 whole drops of water on that penny is because of a special characteristic of water called surface tension. Now you should remember surface tension from our first science experiment last week with the pepper, water, and soap when we practiced proper hand washing. Surface tension is that special characteristic of water that allows it to stay together. So we saw all those drops on the penny, they didn't stay separate. They all came together as though they were holding hands, right? So when we went over that last experiment, I asked you to think about the game Red Rover. In Red Rover, you and your teammates are all standing next to each other, hand in hand, and you don't want anyone to break through your row of friends holding hands in the game Red Rover. So water, just like a team playing Red Rover, likes to stick together. So that water formed a dome shape on top of the penny because it was staying together as best as it could. And then there were too many drops of water once we hit 40, and it just couldn't keep up or hold that strength together. But hey, 40 drops of water on a penny is pretty good, right? Now, like we saw in our hand washing experiment, when we added soap to the pepper and water mixture, it made all of the pepper scatter away. And we said the reason for this was because the soap broke the water's surface tension and how it all stayed together. So take a second and think, what do you think would happen if we added soap to drops of water on a penny? Let's find out. So now I've got that dome of water back on top of the penny. I'm going to take a little soap on my dropper and I'm going to add it onto the dome of water and see what happens to the surface tension. Think about it. Do you think that the water droplets will stay together or break apart like in our experiment with the pepper. Let's see what happens. Ooh. Now that was only... So friends, just as we saw in our hand washing experiment, soap broke the surface tension of the water on the penny. That dome of water was nice and steady, and then we added soap and it broke apart. So the soap, like in that game of Red Rover, is a really, really, really strong teammate on the other team that's able to break through all of your team holding hands together. So that's how we can think about surface tension. Now, if you're trying this experiment at home, give it a shot with some other liquids around the house. Maybe you can use olive oil. What do you think would happen? Would olive oil break surface tension? Or you can use juice, milk. If you give it a try, please leave a comment for your classmates so we can learn a little bit more. And of course, leave a noticing and wondering or something that you liked about the experiment. Thanks for watching.